Whilst we're on the topic of physics, I might as well tell you Newton's second law. So Newton's second law says that for every action, there is an equal and opposite reaction. So action could be a pull or a push. So when you push something in this direction, there's an equal and opposite reaction. It means that something else is pushing back. Um, well, when you push something in this direction, there's something happening in this direction as well, and the size of this push is equal to the size of this push. That's what this equal means. So when you push something in this direction, something's pushing back of an equal size, okay, but in the opposite direction. So what that means is, if you look at this here, let's say you and your friends are sitting on one of those wheelie chairs. If you push against your friend here, your friend will go in this direction, but then you also go in this direction, and the harder you push, the harder this opposite reaction will be. So if you push really hard, your friend will go really far back, but then you also go really far back. If you push gently, your friend will move gently across. You will also move gently across. So for every action, meaning for every push or pull, in this case is a push. For every action, there's an equal and opposite reaction. See, you see the size of this is the same as the size of this. Okay, so it's just now imagine this is you here, and the Earth is here. Okay, because you're in space. Remember, there's no friction in space. So imagine you're in space at the moment here. Well, now this is you standing on Earth. When you jump, you move up. But the thing is, you also push the Earth downwards, so the Earth actually moves. But because the Earth is so much bigger and more massive than you, the Earth does actually move, but it moves a tiny microscopic amount. Whereas you, because you're so light in comparison to the Earth, it seems like the Earth is standing still. But in fact, when you jump, let's say here, okay, when you jump, you're up here. You're moving away from the Earth, but the thing is, the Earth is also moving away from you. But because the Earth is so much heavier and so much more massive, it moves a tiny microscopic amount, which you don't actually notice. So when you jump, you are actually moving away, and the Earth is also moving away. But then, because of this law, F equals G m1 m2 over r squared. When you jump, this law takes over. So this law will pull you and the Earth back together again. I've done some videos on this law already. Basically, it says that when two things have masses, this and this, they have a tendency to come together. So you have a mass, the Earth has a mass, so you two will come together. Okay. Newton's third law, for every action there's an equal and opposite reaction. So when you jump, you're actually pushing the Earth away from you, and the Earth, in theory, it moves away from you. Okay, so the Earth also moves away. Well, the Earth also moves away from you. So you move up really high. The Earth actually moves away from you, but by a microscopic amount. So imagine you're in space. So in space there's no friction. So you're just going to float there in space. Let's say you're at rest at the moment. You're not moving about. You're stationary. Now, imagine you've got a snooker ball here. If you throw the snooker ball in this direction, the snooker ball will constantly move at a constant velocity unless acted upon by an external force. So the snooker ball will move in this direction. But the thing is, you also move in the opposite direction. So here, if in space you are stationary, if you can't really move about. You can't. Well, if you want to move in this direction, what you do, take a load of snooker balls with you. Okay, let's say you've got you've got many snooker balls on you. Okay, if you want to move in this direction, what you do is you throw the snooker ball in this direction. So the snooker ball will move at a constant velocity in this direction. So it keeps on moving this direction. But because Newton's third law says that there's an opposite reaction, when you throw a snooker ball in this direction, you move in this direction. Okay, so if you want to go in this direction, throw a snooker ball in this direction, and if you want to move even faster, throw another one in this direction. Yeah, because the snooker ball moves in this direction, there's the opposite reaction. You go in this direction. If you want to go up, then throw the snooker ball downwards, so you will go upward. Okay, well, so on and so on. Okay, and that's, well, one of the reasons why it's hard for you to step off a boat onto a harbour is because inside your mind you either don't know about Newton's third law or you forgot about it. It's actually quite hard because when you move, when you want to go in this direction, you have to push back in this direction. So because there's inside your mind, you think that the boat will stay still, but it doesn't. It actually moves. It moves away from you. So that's why it's hard to step off a boat when well, it's hard because inside your mind you're thinking that the boat will be stationary, but in fact when you move in this direction, you're actually pushing back against the boat, and the boat moves away from you, and then you miscalculate the harbour, so you actually fall into the river. Well, sometimes it's hard to do that. Okay, it's a bit like you doing this. You see, if you had if you had a normal chair, this is easy to do, jumping onto the bed. But if you were on one of those wheelie chairs, this is actually quite hard to do because you thinking that the chair will stay stationary, it wouldn't, because when you move in this direction, you're actually pushing the chair in this direction. But because the chair is on wheels, the chair is going to move, and this is actually quite hard to do. And also on the previous video, this explains why in the previous video this scenario doesn't work. If you want the boat to move in this direction, if you push on here, it doesn't work because you are actually going in this direction. We'll watch the previous video if you don't understand what I'm talking about. So here again, if you want to move the boat in this direction, it doesn't work here because when the fan pushes in this direction, there's the opposite reaction. The fan wants to move in this direction. Okay, so because the fan is stuck to the bolt, it's actually moving the boat in this direction as well. So here you've got the wind that's blowing in this direction, while pushing the boat in this direction, but then the fan is also moving in this direction. So the two will cancel each other out. It doesn't work. Okay. Same with this. If you push against a rocket in space, because here Newton's third law says that there will be an opposite reaction. So here, between your feet and the ground, you're actually pushing in the opposite direction. That's why it doesn't work. Okay.